Section 7.2, question E18. This starts to get into some pretty abstract concepts. I strongly recommend that you try example 7.5 in the book first. Go through that on your own. I'm sure you will have some questions as you go through it, and then come back to this problem. Once you're ready, though, let's take a look at what we're being asked here. So we have 9 riverboat casinos in Illinois, total number of people they admitted, how much on average people lost, and of course some people won, but we're just looking at an average of these 16.5 million people, and we know for sure that the average will be a loss for the people, a win for the casino. And we're given a standard deviation. So we're actually given the parameters for the population already. The parameter mean is 120.02. Parameter, the population standard deviation is 100. So what were the total winnings on gambling? I'm going to work through this problem in Excel with you. So we just need the total number of people times the win per person on average for the casino. And so I'm just going to create a quick formula here to multiply these two, and that gives us the total number of dollars that the casinos won there for the year. What was the average win on gambling per casino? Well, here we just take the total amount of money that the casinos won, divide it by 9, and of course, this is not the amount that each one won. Certainly, some of the casinos were bigger, but because we're looking for average, this is exactly what we need to get. So here's where it gets a little bit different. We randomly select 100 people out of this 16.5 million population, and we're looking for the probability that the mean win per person was over 125. So let's take a step back. What would we do if we were just selecting one person? Well, if we were selecting one person and we wanted to see whether their win was over 125, we could just calculate a z-score for this 125. In other words, 125 divided by, or minus 120 divided by the standard deviation, and then we could look that up on the table A or use calculator Excel to find the cumulative standard normal distribution. An interesting question would be what percent of people win in casinos, and in that case we would just need to be looks like 1.2 standard deviations below the mean, which would be roughly, I don't know, maybe 13-14%. So roughly 13-14% of the people who go to the casino actually go out winning money, which is an interesting statistic, I think. But that's not what we're looking for here. We have 100 people admitted. Now we want to know what the probability that the mean win for the casino is over 125. So the first thing we need to acknowledge is that this is going to be a much smaller chance than just a single person. So a single person at a casino, you can imagine, could do very well, could do very poorly. Any of those are very possible outcomes. If we have 100 people, the more people we get in our sample, the closer we're going to tend to be to this population mean. It's going to be harder and harder to get these outrageous values the more people that we have in our sample. And so we're given a formula in the book. We have standard deviation divided by the square root of n. So instead of using this 100 in our standard deviation formula, we're going to have to divide that based on the sample size. So our sample size here is 100. So n equals 100. The square root of that would be 10. So we're going to have to adjust this standard deviation by dividing by 10. In other words, instead of using 100, we're going to use 100 divided by 10, or in other words, 10. And what this is called is the standard error. Again, this is the standard deviation of the distribution of sample means. So instead of the original distribution, which had a standard deviation of 100, this is the adjusted standard deviation for when we have an entire sample of people. Okay, so with that in mind, now we can just take a simple z-score. So we know that we have 125. This is our x value. This is our population mean. This is the standard deviation we're going to use. It would give us a z-score that we could then look up on table A. Instead of doing that, I'm going to show you how you can do it in Excel, although that would certainly give you the same answer. So I'm using the normal distribution, and as soon as I type in NORM, I'm given a few different options. I just want the normal distribution, so I put .dist, give myself a parentheses, and then as always, Excel gives me prompts for what I'm supposed to input. First, I'm supposed to input my x. So this is the specific value that I'm interested in for this problem. In this case, it's this 125 cutoff. Now I have a mean that I need to put in. This is my population mean of 120.02, asking me for the standard deviation. Because I'm working with a sample of 100 people, I need to put in the standard deviation of all samples with 100 people, which is 10. Notice that's not the 100. And then cumulative, I do want cumulative because this is giving me all the values up until that cutoff point of 125. And when I press enter, it gives me 69% roughly. Notice that this is far off the answer given of 0.30. So what's going on here? This is the percentage of people that have up to or less this 125. In other words, the casino won $125 or less. But the question is asking us how many were over this 125. So we take 1 minus this value, and there's where we get our 0.30. Notice that this is slightly different than the answer given here, and that's just going to be how the standard distribution was used, the standard normal distribution. If you used a table, it's probably going to be slightly less accurate than using a computer program like Excel. But the tolerance is 2%, so it should count that. Okay. Now just for kicks here, let's look at, so we're going to go the normal distribution again. Let's look at what the chance would be that the casino does lose money. So let's look at 0. In other words, the break-even point between the casino and the person. And we still have the same mean, 120.02. But here, because we're just looking for any given person, what's the chance that they can beat the casino? We do want to use the 100 standard deviation. And yes, we do want cumulative. We could also put a 1 instead of true. That would be fine. So 11.5% chance that a given person will beat the casino when they play. Notice a better way to say that, to show you of the dangers of gambling, is that 88.5% of the people who walk into a casino on average will walk out of that casino having less money, assuming they did some gambling inside. Okay, back to this, we have the probability that the total winnings for the casinos from these 100 people was over $12,500. Notice that this is exactly the same question. If we have 100 people where the average win for the casino was over $125, then all we need to do is multiply these two to get the total amount that the casino won there, $12,500. So this is asking the exact same thing. This is important because you will see this showing up in several of the other problems where the question could be asked in either way. They could ask for the mean of a specific sample the probability that the mean will be in a certain position, or they could ask for the total for a certain size sample. And you can convert back and forth just by dividing out to get the mean in either case. So in this case it would be given. In this case you would take the 125 or 12,500 divided by 100 to get the x value that you would use in your z-score formula or in Excel. If you randomly select 100 people, what's the probability that the mean win for the casino would be less than 0? So what we had done here is we had calculated if we have a single person walking into the casino, then they have an 11.5% chance of winning. In other words, the casino would have an 11.5% chance of losing. But that was a single person. Let's take a look for a group of 100 people. What's the probability that as a group, those 100 people would walk out of the casino as winners? So we start off with the normal distribution again. Here our x value is once again 0. Our mean is 120.02. The standard deviation, so what is this going to be? Is it going to be this 100? No, because remember, this is only for a single person. Here we're looking at a group of 100 people, so we need to use the adjustment formula to get the standard error. And we've already calculated this for a group of 100 people. The standard error is 10, so we can input that. And here, just to show you, instead of writing out the word true, I'm going to put 1, which will give me the same thing. And we're given 1.734 e negative 33, which means 1.73 times 10 to the negative 33. In other words, it's a decimal point with 32 zeros and then 17. So it's extremely, I don't even know the term for that. So 1,000th, 1 millionth, 1 billionth, 1 trillionth, 1 gazillionth. Whatever it is, it has 32 zeros in it. So it's an extremely unlikely number. So if you're ever leading a tour group of 100 people, going to a casino with the hopes that your group will win money for some fundraising efforts, you better hope that you're extremely good at counting cards, because probability would say that's not going to happen.